Let me get back to my share screen. Okay, so again, we talked about several times how you should be doing the one mean t-test or the two mean t-test, because for none of the variables in any of the data sets do you know the population standard deviation. Okay, and so I'm limited to the t-test. Question 6 then wants you to calculate your test statistic using your mini tab stuff. Naomi, am I going too fast?
You're good.
Okay, so we're going to figure the stat basic statistics. We're doing the one sample T in this case. And my data this time is my height in centimeters. I am performing a hypothesis test. My hypothesized mean is 175.4. If the instructions don't tell you, and I don't remember if it does, you can decide whether you want to use a 95% or a 99% confidence interval, level of significance. Again, the most popular, the most used is 95, so I'll leave it at 95. And then my hypothesized mean was that it was greater. I click OK and OK. Okay, remember, I'm looking for the information under test, copy. It does tell you to copy the results, but it also says, and you guys have been doing a good job with this, is to record. Okay, so record means to write it down, ideally in a complete sentence. So you would say the t-test statistic is 4.54 with a p-value of 0.000. Now you could write just 0, but it does write it out in 3 places. Okay, it's real. You're at this point, once you get to question 3, you are basically following the steps of any hypothesis test. You're stating the hypotheses. We've already identified the variable we're using, so we've identified the players. Step 6 is you've calculated your test statistic. Step 7 is we're going to decide, or question 7 on our paper, which is the next step in the hypothesis test, is to make a decision. Okay, and we're going to compare the p-value, which is 0, to the level of significance. Now again, you can choose. I would recommend using 0.05 because that's the most commonly used. And we find that when you make that comparison, 0 to 0, 0 to 5, that the p-value is less than or equal to the level of significance. When the p-value is less than or equal to the level of significance, we reject the null. Okay. And it says state why. Your why is because the p-value is less than or equal to the level of significance. That's the reason we reject the null, is because the p-value is less than or equal to the level of significance. That's what it's always been. So the last thing is to write your final conclusion. So I'm going back up here to my hypotheses. We have said we're going to reject the null, which means our null hypothesis is false or invalid, and the alternative is true or valid. Okay, so we have to write it so that it indicates that in this case, the height of the American U.S. presidents is greater than 175.4. So we would say at the 0.05 level of significance, the average height in centimeters of U.S. presidents is greater than 175.4. Okay, so you're conducting, once you get really the first two steps where you're identifying the variable and then coming up with your own hypothesis is kind of the new piece. Okay. And then the rest of it is just like running a straight out one mean t-test. You're stating the hypotheses, you've identified the information, you have the raw data, you calculate your test statistic and p-value, you make a decision and write a conclusion. Are you okay, Naomi?
Yes, I'm okay.
Are you think you'll be able to follow that?
Yes.
Again, you can Google, you may not use height in centimeters since Miss Ralston used it. Okay, you can do height in inches, weight in pounds or kilograms. You could look at, although the IQ issue may be a little off, you could do IQs if you wanted to. Again, you could look at age, you know. Jeannie, do you feel comfortable enough with doing the two mean, or do I need to maybe find an example of a two mean?
I think I feel pretty comfortable. I actually just ran it through, and you know, and it's like they at the proficient level, and I like the idea of doing that since I've already said that it's a normal, you know, the interesting already established that it's a normal distribution, and so just comparing. Do you think it's okay? I'm comparing all grade levels, but if I start to drop grade levels, I don't get as many.
Right. Yeah, all grade levels is fine.
Okay. Yeah, no, I think that I feel pretty comfortable with that.
Okay. While we're here, may I go ahead and give you a heads up about mini project 5 related to Anova? Would that be okay with the two of you?
Yes, please do.
Okay. So for mini project 5, you're going to be doing an Anova. Okay. And so remember, with Anova, you have numbers that you can sort with a qualitative variable. Okay. You have numbers that are sorted by a qualitative variable, and Minitab will do the sorting for you, so you don't have to do it yourself. The data set on the presidents is a little bit limited, Naomi, on the quantitative variables. So you could look at maybe their age sorted by the body mass index. You could look at their height sorted by their birth state. I mean, there's, you know, you've got, as far as qualitative, you've got astrological sign, you have birth state, you have the body mass index, and there was one other one I was looking at earlier. Oh, the political party. Okay, so for example, and I'll do this one and then I'll come back and talk through one with you, Jeannie. Okay, so let's say that we want, I'll get back to it, maybe for the president's one, and I'm going to do one maybe that's kind of crazy. Let's say that we want to look at their height in centimeters, sorted by astrological sign. Okay, I mean, you can pick whatever you want. So I'm going to pick the height sorted by astrological sign as my data. And then I can do my own research. But remember, with Anova, we're either kind of saying that all the means are the same or all the means are different. So, you know, maybe my hypothesis is that I want to test the claim, if I can spell, that all the mean heights are the same for each astrological sign. Okay. Now, I mean, I realize that in the overall real world, that's not going to make a hill of beans. And I mean, if you're doing more real data, that would be more common sense. Okay. So I've used my own research, my own gut, made up my own hypothesis. And then really I should write that hypothesis on number 3. From there, once you have kind of determined what you want your hypothesis to be, from there, it becomes really a standard hypothesis test. So we might have, for, again, you write your null hypothesis. So my null hypothesis would be, you know, all mean heights are the same for each astrological sign. And that is my null, because the idea of them being the same implies that they're equal. The alternative then, which is the exact opposite, would be not all mean heights are the same. You could, I mean, I'm saying they're not all the same. You could say at least one differs. There's lots of ways to say it, but again, typically with Anova, the null will imply that they're equal or the same, and the alternative will imply that they're different or not equal. Okay, so we've written out our hypotheses, which is the same process we used on Tuesday. Our data is the raw data in the data set that you have uploaded to Minitab. And this process is just slightly different because before, in the homework problems and in the examples we looked at on Tuesday, your data came or was given to you already sorted. Minitab will do the sorting for you if we choose a slightly different command. So these steps are just a little bit different, so you may want to take note of it. So we still go to Stat, Anova in one way. On Tuesday, we had each of our data in a separate column. This time we have all the data in a single column. We have all of the heights in a single column. The height, remember, the quantitative variable is the response. So the height in centimeters is my response. The factor is your qualitative variable that you are sorting by. And I elected to sort by astrological sign. Again, I go to options and I'm going to leave it at 95%. We do assume equal variances and it's two-sided. I don't believe the project asks you to run 2K, but if you, wanted to run 2K, remember you go to comparisons and click on 2K. And I click OK and OK. And it thinks about it. And we get our analysis of variance table that contains our F value. And again, it does ask you to copy and paste that, but it also says to record, which you guys are doing a good job with. I'm having trouble with the other class not wanting to write it down. Okay, so we would say the F test statistic is 1.05 with a p-value of 0.425. Then we're going to make our decision. Okay, then we're going to make our decision. So again, to make our decision, remember we compare the p-value to the level of significance. My p-value is 0.425. Again, we elected to use 0.05. It does say use 0.05 right here. Level of significance. If I compare those, 4 to 0, 4 is greater than 0, so P is greater than the level of significance. When P is greater than the level of significance, we fail to reject the null because P is greater than the level of significance. Again, it asks you for the why, so you need to include the statement. It's because the p-value is greater than the level of significance. So then I have to write my conclusion, so I got to think about what my conclusion would be. We fail to reject the null, okay? And if we fail to reject the null, that means the null is true or valid based on the evidence we have, and the alternative would be false or invalid. So the evidence, based on the evidence that I have, it indicates that all mean heights are the same for each astrological sign. So that's what I have to say. Make sure you include your level of significance. So we would say at the 0.05 level of significance, the mean height of, I should say in centimeters, mean height in centimeters of U.S. presidents are the same for each astrological sign. Okay. Now, again, you're not asked to do 2Ks, but I can also come over here and look at the means for the astrological signs. And it looks like they're different values, but again, the difference that occurs there, they range from, let's see, there's 173. Looks like a low of about 173 to a high of 187, but that difference does not appear to be statistically significant. We could look at the plot if you wanted to for 2Ks. You're not required to, but just to kind of, well, let's see if I can move that down a little bit. Come on, move down. It's not going to move down for me, but you can kind of see all of the bars, all of them kind of overlap a little bit. So that overlap again indicates that they are all basically the same because they have that in common. There's not one that's way out of whack. Now, Jeannie, for your data set, let me see if I can pull it in.
I was actually kind of looking at that, and it there's a couple of different ones. Like I could do an Anova for the I think for the, like if I wanted to like compare the academic levels, the third, fourth, fifth, I could do that. Was I initially did it with the schools, but that was a whole lot.
The schools were a whole lot because I was playing with it right before class, before we came into class. I did look at one like how many, what the I think I did proficient. What did I do? I did the proficient percentage with the grade, like by grade levels, to see if there was a difference.
Exactly, the academic levels. That's exactly what I did, and it's a little more. It's still kind of daunting. I was thinking, it's still a lot, but it was manageable.
Yeah, but I have run it by the schools before, and there's just so many that you can't get a good picture.
Actually, you could go back out. I could go back out and start working with different, like drop the all students and start working with subgroups.
Yeah, you could.
I could like re-pull and do a breakdown in subgroups and look at the Anova. Actually, that would be interesting. Subgroups in the different.
I had this data set pulled in earlier, so I know it's on my computer somewhere. It's just a matter of where did I put it.
It's in the cloud.
Yeah, I've got it in the cloud, but I had it. I guess it's still in here, but I had it pulled in. I had actually one semester when we first started teaching this course and I was using this data set, I had a student who was interested in the education one. So I actually did a lot of the sorting for her by hand at that time because I wasn't as overly familiar with
it's kind of a brutal data set because it's got so much aggregate, it's like aggregating in so many different ways. I understand it now, but initially it was I was like, there's too much here, it's really a challenge to try to kind of corral it.
Yeah, I think I took and like pulled out a certain grade or certain?
I think you had like there was in the data set, Bartow County had been already.
Yeah, I had pulled out.
Yeah.
She lived in Bartow County.
Okay.
So the student that I was working with, and so I sorted out like Bartow County.
Yeah.
Oh, there it is. There's the one I had. Nope, that's not it. I know I have that data set on here somewhere. Well, right there it is. Why is it not coming up on my, oh, good heavens.
Technology.
Oh, you gotta love it.
I know you do.
Well, right there it is. It takes a minute for it to load because it's such a big data set. But I think that's a good approach. Like I say, I had it sorted in Bartow County, but like I was looking at this morning using the whole data set and doing it by grade levels. If I tried to do school systems, like you say, that's way too many.
Right. But I was thinking actually dropping it back out, you know, going back out again and then bringing in some of the student types. Like for one, I did students with disabilities, you know, like doing some of that just, and that would be like an interesting Anova to compare.
Yeah. Yeah. See, it looks like I don't remember now what I pulled. They're sorted by school districts, maybe.
Yeah, they are definitely sorted by school districts.
I don't know what so I had them sorted and I pulled some numbers, but like if you're in this big data set, you know, you could even do like which test, are all the tests the same? You could sort by the test component.
That's
so like
true.
And you can
just, so I could actually go back out and grab, because I thought it would be more interesting to kind of follow along with math, you know, and just because my husband's always observed things about math. I was kind of interested to see if it was true, you know, if it was the case, you know, what he had.
But like if you want to do the precision, you know, how many scored proficient, and then maybe look at which test. You know, that sorts it by the different tests.
Right.
And does all means are equal, not all means are equal.
Yeah.
So you may want to pull back out and, you know, or look at the math by grade level. Is there, you know, do they start out maybe kind of
the same,
or do they get at some point, do they go different when they get higher and higher ups? It almost would be but Anova's not going to tell us that. I mean, it's going to tell us there's a difference, but I wonder if there's you know, are they making progress like from third grade to fourth grade? But Anova's not going to show us that, but it would show us that there is a difference, and then maybe 2Ks we could look and see, is the difference getting maybe higher?
Right.
But do you need me to walk through, or you feel pretty good?
I think I feel pretty good. You know, I was looking at I pulled out the Turing t-test, so I feel pretty good about that. And then the Anova, this gives me some ideas for what to do for the Anova.
Yeah, and the Anova's not due until November the 7th. And so that gives you a little bit of time to, you know, think about it. And then if you do have additional questions, we can always come back and revisit that if we need to next week. Naomi, do you have any additional questions that I can try to address?
No, I don't have any questions.
Okay, let me show you what's out there and where we're headed. We are actually, today was scheduled to be a catch-up day, so I feel like some of the things that we're doing, kind of walking through those mini projects, reviewed the material a little bit and is giving you kind of a heads up. In module 4, which we'll start on next week, we're going to get into linear and multiple regression, a 1 and 2 proportion test, and then the chi-square test. For linear and multiple regression, we actually don't do multiple regression. I'm not sure why she has that listed there. I have a set of fill in the blank notes. That is a topic that we also cover in Stat 1401. And so when COVID hit in the spring of 2020, I created those fill in the blank notes for students because it's another one of those very lockstep processes, sort of like hypothesis testing. You go through the same steps over and over and over and over again. So I have those available if you want to have them printed off when we start and start filling in the blanks. And I did create a PowerPoint that has a lot of the same information with a little bit more detail that is available, and I may refer to it some in class as well. But I don't want to overwhelm you. So at this point, you have quiz 9, which is over Anova and Kruskal-Wallace and 2Ks. That is due on Sunday. Yes, on Sunday. Mini Project 4 is due on Monday, which is the 31st. And then Mini Project 5 is due by November the 7th. Okay, so do you have any questions that maybe about any of that I can try to help you with before we finish up? And I am going to finish up a little early today, again, primarily, again, hopefully not to overwhelm you, but give you some time to kind of catch your breath and catch up on things. Okay, are either of you going to be offended if we do finish up early today?
I will not be offended. Perhaps Naomi will be.
Naomi, are you going to be upset if I finish early today?
No.
Okay, so I hope what we've done today has been helpful as far as getting you prepared for Mini Project 4 and Mini Project 5. And then Monday or Tuesday, we're scheduled to begin the discussion of linear regression, which is what we'll do. Okay?
Yes.
Well, I will see you guys on Tuesday. Y'all have a good weekend.
Thanks, Lauren. Y'all have a good